Hello, data analysis. Welcome to the last day of geometry review. Next week we'll start talking final and how that's all going to tie in. You'll see in the Learning Launch email I send you. Don't have a joke today, but I have a funny picture to show you, and here it is. I'll need a little background explaining. My son, who's 6, loves glow sticks. You probably grew up playing with glow sticks. He likes to take them and hang them on his bed and stuff when he goes to bed. And he's kind of goofy. Well, we found some glow stick glasses, right? So he goes to sleep tonight. And here's the picture of him sleeping tonight. He fell asleep with his glow stick glasses on. Very good looking, obviously, with those. So I thought you'd appreciate that tonight. So on to something more and more exciting, way more exciting. How do we find the volume of cones, pyramids, and spheres? Starting with cones, there's an activity we'd do in class quickly that would show you that if you took a cone and a cylinder, right, that have the same radius, whatever the radius is here, same there, the same height, the height is here, it's the same there. They have the exact same, and I filled this up with water, right? Because there was no bottom on it, like if it was upside down like this. And so it's basically a cup, you've seen, or a sugar cone, like an ice cream cone, right? So it's got no bottom on it. You can fill it with water. And I dumped it into this cone because into the cylinder. There's no top to it, right? So I dump it in there and then I fill it up again and dump it in there. I keep doing that because when I know this formula for volume, area of the base times the height, that's what we learned yesterday. So it's pi r squared h. This formula I can figure out using how many times I dump it in there, because it's going to be the same formula if it fills it up the same number of times. It's just how many times it fill it up. And the answer is, first time it fills it to here, second time it fills it to here, third time it fills it to the top. So it takes 3 times, 3 cones to go on into there. So the formula for volume is 1/3 area of the base times the height, because it's 1/3 as big, because it takes 3 times to dump it in there. So let's go right into our first problem here. So let's say I told you that this radius here was 3 inches and this height was 4 inches. Notice I'm not doing the slant height now. I'm doing the height, which goes right through the middle of the cone. That's 4 right there. So volume equals 1/3 area of the base. So now remember, area of the base is a circle, so it's pi r squared times the height. So actually, that's your formula for volume of a cone, if you need it. 1/3 pi times 3 squared times 4. Okay, so I'm going to put that in my calculator if I can find where I set it, which you know how it goes. Before I started presenting, I should have checked to see where my calculator is, but that's all right. It's long gone. I can probably do this in my head. So we'll leave it in terms of pi, because I can't multiply pi in my head, but 1/3 pi 9 times 4. So this is 3 squared is 9, so 1/3 of 9 is 3 pi times 4. Because when you multiply, you can multiply all parts together in any order you want. So it's not 1/3 times all of it. I can go 1/3 times 9. That's fine. So then volume equals 4 pi. And this is going to be, now it's radius squared, so it'd be inches times the height is in inches, so it's 3 inches cubed. So that's something like 12 point whatever, because it's 4 pi's, which pi is 3.14. So something like that, we'll just leave it in terms of pi because my calculator's not here. Or you can put it in your calculator and finish it up. Next idea. All right, so let's say I draw a pyramid, but I draw that pyramid upside down. Okay, so there's my pyramid upside down. And then I draw a cube. Whoa. And my cube has the exact same size, base, and height as this pyramid. All right, so this length here, let's say that length is x. All lengths would be x. And the heights, okay, would match the height of that pyramid. So height now, right through the middle of it, it would match this height right here. Okay, and if I take this formula, area of the base times the height, capital BH, and I fill this with water, no bottom on it here, and I fill it, there's no top here, and I fill it, I'm going to fill it up 3 times, and that's exactly what it holds. So the same formula, area of the base times the height. Okay, So let's say I give you some numbers. So let's say the area of this base, or I would say the length of this base is 10, and the height, let's make it be 15. Okay, so volume equals 1/3. Now this base here, this base is a square. Okay, the base is a square, 10 by 10. So the area of the base is 10 times 10. So area of the square is 10 times 10. So area of this base is 10 times 10 times the height, which is 15. Okay, volume is going to be, that's 100. A third of 15 is 5. So 1/3 of 15 is 5 times 100 is 500. And that would be cubic units. So if I don't put any units on it, it would be units cubed. So that's how you find the volume of a pyramid. Okay, so again, the representation with water is that we would pour it in class, and I would show you that it takes 3 times. So we use our old formula, we just multiply it by 1/3, and you get the new formula. So if I say, what's the formula for volume of a pyramid? You can look it up, or you can just say it's a third area of the base times the height. Cones the same way, third area of the base times the height. Let's do one more today. So let me move to a sheet of paper that's not as messed up there. Let's do a sphere last. Sphere, there's a good way to show you how I come up with a formula, but it takes a long time. So I'm just going to give you the formula. Let's say I have a ball. Let's call it a basketball, 6 inches in diameter. And the formula for volume is 4/3 pi r cubed. 4/3 pi r cubed. Volume equals 4/3 pi radius, which is 6 inches, cubed. Volume is 4/3 pi. 6 cubed is 216. Now it's inches times inches times inches, so it'll be inches cubed. That's what I want. And volume equals, let me see if I can do a little math in my head here, because my calculator can't find it. I could go on a decimals, but I think I got it here. 216 divided by 3 is 72. So that would be 4 pi times 72. So I just took 216 divided by 3. Again, just put all this in your calculator. Volume equals 144 times 2, 288 pi, and that would be inches cubed. So calculator is fine, or you can leave it in terms of pi. That's an exact perfect answer. So you have 3 formulas. One for sphere, volume of a sphere, and the formulas for, that's the wrong page. Formulas for a cone and a pyramid are exactly the same, except the area of the base for a pyramid would be length times width. The area of the base for a cone is pi r squared. So when you're doing the practice problem, make sure you use those formulas, and you should be great. Almost as great as this guy right here. Almost as great. Talk to you later. Bye.